Hi everyone! In this video, we're going to explore the States of Matter Basics simulation on PhET. First, let's go to https://phet.colorado.edu/en simulations States of Matter Basics. You should see States of Matter Basics on your screen. Click the play button to launch the sim. When the sim opens, you'll see two options at the middle of the screen, states and phase changes. Today, we're only using the states screen. Go ahead and click on that. Let's take a quick look at the screen before we do anything. On the right side, you'll see a list of 4 substances you can choose from: neon, argon, oxygen, and water. We'll be working through all 4 of these today. Below the substance list, you'll see 3 buttons: solid, liquid, and gas. These let you jump directly to that state. We'll use these when we fill out the data table. In the center of the screen is the container. This is where you'll watch the atoms and molecules move. Keep your eyes here during the simulation. On the left, you'll see a thermometer showing the temperature. You can switch between Kelvin and Celsius using the small arrows at the top. For today, let's keep it in Kelvin. At the bottom center, you'll find the heat and cool controls. Clicking heat adds energy and raises the temperature. Clicking cool removes energy and lowers it. That's the full interface. Now let's start exploring. Before we start recording any data, let's just play around with the simulation to get comfortable with the controls. Click on water on the right side of the screen. You'll see molecules packed tightly together inside the container. Each one looks like a small orange atom connected to 2 white atoms. That's a water molecule, and right now they're in their solid state, like ice. Now look at the bottom of the screen. You'll see a control with heat on one side and cool on the other. Click and hold on the heat side and watch what happens. Make sure to keep holding the mouse. A few things to notice: the molecules start moving faster and more loosely. The thermometer on the left goes up. The molecules eventually spread apart. That's the water-changing state. Now try the opposite. Click and hold cool and watch the temperature drop. The molecules slow down and pack back together. Go ahead and experiment for a minute. Try heating all the way up, then cooling all the way back down. Water is a great one to watch because it stays liquid across a wider range of temperatures than the other substances. Pause here, take a minute to explore, then press play when you're ready to continue. When you're ready, we'll go through all 4 substances and fill in the data table together. Welcome back. Now we're going to work through all 4 substances and fill in the data table together. Your table has 3 rows, solid, liquid, and gas, and 4 columns for neon, argon, oxygen, and water. Pause here and make sure your table is in front of you before we start. Let's start with neon. Make sure neon is selected on the right side of the screen. Click the solid button. Watch the cyan blue dots. They're packed tightly and vibrating in place. Look at the thermometer on the left and read the temperature. You should see something around 14 Kelvin. Write that down in your neon and solid box. Now click liquid. The dots are now moving more freely, sliding around each other. Check the thermometer again. You should see something around 28 Kelvin. Write that in your neon and liquid box. Now click gas. The dots are flying around quickly with lots of space between them. The temperature should be around 56 Kelvin. Write that in your neon and gas box. That's how it works. Now it's your turn. Pause this video now and follow the same steps for argon, oxygen, and water. Click each substance, go through solid, liquid, and gas, and record the temperature for each one. Come back when your table is complete. Welcome back. Let's check your answers. Here's the completed table. Check your answers, or just take a moment to read through all the values. For argon, you might have noticed the numbers jump up quite a bit. Solid is around 43 Kelvin, liquid around 86 Kelvin, and gas around 189 Kelvin. For oxygen, the solid is around 27 Kelvin, liquid around 57 Kelvin, and gas around 113 Kelvin. And finally, water. This one is quite different from the rest. Solid is around 146 Kelvin, liquid around 286 Kelvin, and gas around 430 Kelvin. Those numbers are much higher than the other 3 substances, and that's actually really interesting. We'll talk about why in the next segment. Question 1. Which of the 4 substances has the most energy of movement in its solid state? How do you know? Take a moment to pause the video and write down your answer before we go over it together. The answer is neon. Look at the solid row in your data table. Neon is at 14 Kelvin, argon at 43 Kelvin, oxygen at 27 Kelvin, and water at 146 Kelvin. Neon has the lowest temperature in its solid state, which means its particles are moving and jiggling even at extremely cold temperatures. Go back to the sim, select neon, and click solid. Notice how the cyan blue dots are still jiggling and bouncing around even at just 14 Kelvin. Now compare that to water in its solid state at 146 Kelvin. The molecules are much more tightly packed and barely moving. Even though water is at a much higher temperature, neon's particles actually show more visible movement in their solid state. That movement is what tells us they have more energy. Question 2. Which of the four substances must be at the lowest temperature to stay in its liquid form? Take a moment to pause the video and write down your answer before we go over it together. Welcome back. The answer is again neon. Look at the liquid row. Neon is at 28 Kelvin, argon at 86 Kelvin, oxygen at 57 Kelvin, and water at 286 Kelvin. Neon has by far the lowest liquid temperature of the four. If it gets any warmer than 28 Kelvin, it turns into a gas. All the other substances can stay liquid at much higher temperatures. Question 3. Which of the four substances is in liquid form at the highest temperature? Take a moment to pause the video and write down your answer before we go over it together. The answer is water. According to your table, water is still liquid at 286 Kelvin. That is close to room temperature, which actually makes a lot of sense, because that is exactly what we experience every day when we drink a glass of water. Water can stay liquid across a much higher temperature range than any of the other three substances we looked at today. And that brings us back to what we noticed earlier. Why are water's numbers so much higher? It comes down to how strongly the molecules stick together. Water molecules are attracted to each other much more strongly than neon, argon, or oxygen, which means you need a lot more energy to get them moving freely as a liquid or flying apart as a gas. Nice work! You have just explored how four different substances behave as solids, liquids, and gases, and discovered that every substance has its own unique temperature range for each state of matter.